Hi everyone. So today we're going to be talking about charging objects by induction. So in this video we're going to talk about conductors, insulators, semiconductors, and the process of induction and how that differs from the process of conduction. So the process of induction and how that is different from the process of conduction. So let's get started. So let's talk about what is a conductor. So a conductor, from a strict definition, are materials in which some electrons are free electrons and that are not bound to atoms and can move relatively freely through the material. And an insulator are materials in which electrons are bound to atoms and cannot move freely through the material. So those are like the definitions, but let's go over like an example and to kind of better understand this. So we have like some material object, just called some kind of block, and each block has like protons and electrons. And so if you zoom in on like a little section of this, you have like the proton nucleus, and then you have like electrons that are like swirling around. You have a proton here and electrons that are swirling around, and you have something of this nature, right? So just make it like a little electrons swirling around, nucleus, electrons swirling around. So nucleus, protons and neutrons, electron cloud, which is just electrons. So a conductor is basically these electrons that are swirling around these atoms can move like throughout the material, for if they have to, like they're not stuck here essentially. Versus an insulator, these electrons, because of protons and the orbital levels and different electronic interactions, these electrons are bound. They're more bound. They're not. They're bound. They're like stuck essentially. They cannot move throughout the material. Like the electron here will always stay with this nucleus here in an insulator, versus in a conductor, the electron here can be pushed to the next proton over here because it's not bound. That's basically what a conductor does. Now, if it has some behavior where the electrons are not so strongly like set next to their own proton or next to their own nucleus, this is what's called a semiconductor. So if you think of it as a spectrum, you have your conductors here, your insulator here, and you have your semiconductor here. So that's the idea of what a conductor, insulator, and semiconductor are. So now let's go to our topic of charging an object by induction. So let's say you have an object here, and it's electrically neutral. So Now let's say this object here is a conductor. So that means the electrons in this object are free to move around. So now let's say we have a rod, and let's say this rod is negatively charged. So as this rod moves closer to this conductor, the electrons here, I'll just put it in different colors, so make them red, will move this way. So you'll have a situation where the electrons start to bunch up on this left side here because they're being repulsed by the negative charge on this rod. So this side here will have a negative charge, more negative charge, and because the electrons on this side moved over, the protons here, there's more protons than electrons on this side, so this side will have a net positive charge. So now let's assume that we did this whole process that we did here, but in this new case scenario, we had this material was contacted with the earth, and the earth is a ground. So a ground is, let's write this out. So a ground is a reservoir where electrons can be put into or taken out of without the reservoir's electrical properties changing much. Or like the change will be negligible to the ground. Like if you're adding electrons into the ground, you're not changing there's a negligible effect on the electrical characteristics of the ground if you put electrons in, and there's also a negligible effect on the electrical characteristics of the ground if you take electrons out. So a ground can provide electrons, or it can provide electrons, or it can take electrons. And so this symbol here is like the ground symbol that's used in most like diagrams and schematics and things of that nature. Okay, so we did this situation, but we're doing it with a ground now. So when this happens, when you bring the rod close to this material, because the electrons get pushed to this side, some of the electrons go through this grounding wire and they go into the ground. So basically you're permanently removing the electrons here. And now let's basically say you cut this wire after you bring the rod close by. You cut this wire here, and now what happens is, because the electrons have left the material and because the electrons have left the material, now you have a material that has a net positive charge, and so now this material, this block conductor material, has been charged by the process of induction. Now to note, this is how you charge an object by the process of induction. If it was done by conduction, you would have to rub two materials together, like in the previous example we did, where the electrons from the cloth go into the slab that we talked about, or into the box that we talked about. So in that case, in induction, there's a contact that happens, which transfers electrons from one object to the other. But in the process of induction, there's no contact that occurs to generate this situation where the object is now charged. So that is the process of induction and how it differs from the process of conduction. And so those are all the topics we're going to go over. We went over what a conductor is, an insulator, and a semiconductor are. We talked about the process of induction and how it differs from the process of conduction with regards to charging an object. So that concludes this video, guys. If you guys have any questions, leave them down on the comments below. If you guys like this video, subscribe to this channel and give this video a like. This is Solve. Have a good day.